Let's talk about absolute value equations. Absolute value. What is absolute value? What's the absolute value of 3? What's the absolute value of negative 3? Not negative 3. It's 3. Why is the absolute value of 3 and the absolute value of negative 3 the same number? They're not worth the same amount. They're two different numbers. Same what? Not difference, but distance from 0. Distance from 0. That's what absolute value is. Autumn, move up a desk. Absolute value is distance away from 0. Okay, so if we're talking about distance away from 0, when we do an equation like the absolute value of x is equal to 6, how many numbers are 6 units away from 0? There's 6 numbers that are 6 units away from 0. There's 2 numbers that are 6 units away from 0. What are those 2 numbers? Yeah, 6 and x equals negative 6. If I plug a positive 6 in there, what's the absolute value of positive 6? What if I plug a negative 6 in there? What's the absolute value of negative 6? 6. 2 answers from one absolute value equation. Okay? 2 answers from one absolute value equation. And that's, it's okay. Not a big deal. All right. Now, where that comes into play with absolute value equations is when we have something besides just a plain x in there. Maybe we have x plus 3 in absolute value is equal to positive 6. It's a little bit more involved. Then stop. So now we have something besides just single numbers. We've got x plus 3 in there. So we've got 2 different things that could be an absolute value of 6. So what we have to do is set up 2 separate equations. One of those equations would be x plus 3 is equal to 6. And the other one would be, where is x plus 3 equal to negative 6? Because whatever's in the absolute value is 6 units away from 0, just like this was. But instead of it being just a plain x, it's x plus 3 in there. So we set up 2 equations at the beginning. Okay? And we're going to solve each one of those. We're going to get 2 answers for this problem. One answer would be x equals positive 3. The other answer would be negative 9. Just by solving those 2. If you plug each of those in one at a time, 3 plus 3 is 6. The absolute value of 6, still 6. If I plug in a negative 9, negative 9 plus 3 is negative 6. The absolute value of negative 6, 6. So that's why both of those are the answers to that equation. So we're going to set up 2 equations and solve. Example C. Absolute value 2x plus 5 is equal to 13. So we have some absolute value, 2x plus 5, is 13 units away from 0. So what are the locations of 13 units away from 0? Positive 13 and negative 13. So we're going to set up 2 equations to find out where is 2x plus 5 equal to 13? And where is 2x plus 5 equal to negative 13? We're going to solve each of those problems. Subtract 5. 2x is equal to 8. Divide by 2. And x would equal 4 for that problem. Now let's solve the other one. The steps should be the same. As far as how you work it, you're just going to get a different answer. So when I subtract 5 from negative 13, I get negative 18. Divide by 2, negative 9. Two answers from one absolute value equation. So when you get an absolute value equation, you're going to set up two regular equations to solve it. Okay? All three of these first examples, the absolute value was by itself already. It won't always be that way. Okay? There's going to be times where we have to get the absolute value part isolated before we can set up our two equations. And those are the ones that tend to give problems in this particular course. So let's start with something kind of simple. Absolute value of x plus 4 minus 3 is equal to 6. So with this one, we've got an absolute value part, and then we've got a minus 3 outside of that that's not inside of the absolute value, and that's equal to 6. So what we need to do is get the absolute value part by itself. So we've got to remove this minus 3 that's there. How do I move that? I'm going to add it over there to the 6. And then I end up with a problem similar to what we had. Absolute value of x plus 4 is equal to 9. What are my two equations that I'm going to solve? And solve each of those. Positive 5 and negative 13. And you can always go back and plug each of those in, and check them in the original. Make sure that they're correct. All right. Devin, Adam, do y'all need to go see the nurse? You sick? I don't care. Sit up. Sit up. All right. What if you had something like 4 and then the absolute value symbol, and x plus 5, 12? All right. What's going on between that 4 and that absolute value stuff? It's being multiplied. Now, here's the thing that is different with these problems compared to a regular equation. You do not want to distribute. Yeah, we want to divide by that 4. Do not distribute into an absolute value. Ever. Ever. Don't do that. Okay? So we want to get rid of that 4 by division. Don't distribute. It's going to cause a lot of problems as far as, because it's an absolute value, you're talking about changing what you're finding the distance. Instead of, what we're really trying to find is the distance away, from 0 of 3. If you distribute, you're finding the distance away from 0 of 12. Big difference in finding a distance of 3 and a distance of 12. So that's why that you would not want to do that. Okay, now we have our setup. Let's set up two equations. What are they? and solve them. -2 and -8. Both negative numbers. That's okay. Doesn't matter. You can check them. -2 plus 5 is 3. Absolute value of 3 is 3. 3 times 4 is 12. That one works. -8 would be -3. The absolute value of -3 is 3 times 4 is 12. So it works in the original. Three, absolute value of 2x minus 7. Close the absolute value. Then minus 5 is equal to 4. Is the absolute value part by itself? No. How do we get it that way? Yeah, we want to move the 5 first by addition. And then what? Divide by 3. 2x minus 7 equal to 3. Now what? What are the equations?
2x minus 7
Now solve each of those. 5 and 2 as solutions to that absolute value equation. They don't get much more complicated than that. Okay, we're going to look at a couple of exceptions here, but they don't get much more complicated than example F as far as length of problem. Let's look at this one. Absolute value of x is equal to -8. When you have an absolute value is really what? What's the definition of absolute value? Distance away from 0. How many of you have used a tape measure before? Most of us, we've used a ruler at some point in life to tape measure. You ever found one that had negative numbers on it?
No, sorry. Yeah.
No. Distance is never negative. You can't go in a negative distance. You go in a negative direction, but not distance. So, can an absolute value ever be equal to a negative number? No, because distance is always positive. So this would be no solution. Because absolute value cannot be equal to a negative number. Okay. Now, they disguise that in this section and in algebra. They kind of try to, make sure you're paying attention to the problem. Like they might have something like this: absolute value of 2x minus 3 plus 8 is equal to 2. And that looks like it's legal, right? Because it's an absolute value equation. It's equal to a positive number. But what do you have to do first? Subtract that 8 and get rid of it so that the absolute value is by itself. And we get -6. And there we have an absolute value equal to a negative number. And that's not possible. You can't have that. So this would be a no solution as well. Absolute value cannot be equal to a negative number. So this one looks like it would be no solution because we've got a problem that's got absolute value in it and it's equal to a negative number. But I need to do what first before I can decide that? Subtract the 13. Is it? All right, so here we almost have the absolute value by itself. It's not quite, but it's still equal to a negative. But this got this -4 in the front. So to get rid of it, I divide by -4. And that gives me a +4. Oh. Does that have answers? Yes. Absolute value, distance of 4. So we're going to set up our two equations for this one. X would be -1 and -9. So before you can decide if something is no solution, you've got to get the absolute value part of the problem by itself first. If you don't have that by itself, then you can't decide. All right? Any questions about absolute value equations? Pretty easy lesson today. You just got to remember to set up your two equations. Don't automatically assume if I get 5 for one answer, the other one's going to be -5. That's not true. Okay. So your assignment for today is on page 393, 3 through 20. Well, let's just do 3 through 31. 3 through 31. Got about 8 minutes here before lunch, so time to get started on that.